the UN Global Platform, part of the UN Statistical Commission 2021. I'm really excited to be bringing you this event and sharing. For those of you who don't know, I'm Tom Smith. I'm from the UK Office for National Statistics, where I am director of the Data Science campus there. But this, with my hat on today, I'm the vice chair for the Global Working Group on Big Data and Official Statistics, along with Niels Plug, and also Rasenga Maluleki, who is the chair of the working group. So really great to see so many of you here. I know there will be people coming and joining us as we go on, but I suggest we're going to make a start because we have a crowded agenda and some great talks, and I would like to leave some space and time for questions and answers from you all. And from the panelists. So before I go on, let me just introduce the panelists so you know who is speaking and who will come through into the sessions. The first up, Lorenzo Di Simone of the Office for Chief Statistician at the Food and Agriculture Organization will be talking about the cases of Senegal and Uganda in the use of Earth observation for official agricultural statistics. So super important. Second up, we have Jasper Verschuur from the Environmental Change Institute at the University of Oxford in the UK, talking on deriving real-time maritime transport statistics using the automatic identification system, that's the AIS global shipping GPS data. And then third, Sean Lovell and Abdullah Gozalov of the United Nations Statistics Division will be talking on the Cambodia's national database CAMSTAT, a successful implementation of the .stat data warehouse on the UN Global Platform. So three really fascinating talks and areas, and really kind of, for me, illustrate the power and the potential of the UN Global Platform. So I'll start with a few words around the platform itself, how we've got to where we are, and what the platform is aiming to do and how it supports work. And then I'll hand over to each of our three speakers in turn. While we're going, very grateful if you could stay on mute, the usual rules that we have all learnt over the last 12 months. And I think we are going to try and do questions and answers in the chat. So if you please use the chat function. But after each of the presentations, we'll have 10 minutes for questions. So use the chat or use the put your hand up if you can see that on the system that you're using. And Catherine and team here at UNSD will keep an eye on this, and I will bring people in for the questions as we go. And if people are shy, I might have a few questions up my sleeve, or I may even point out some people to ask questions who I know will have good ones to ask. Great. So let me start by setting out just a few minutes on what the UN Global Platform is and how we've got to where we are, and the work and the aims for the platform in how this supports big data work for official statistics production and also research and exploration with national statistics offices around the world and associated parts of the statistical community. So a really big topic, obviously, and one that I hope is of close to all of our hearts. So the starting point, the Global Working Group on Big Data and Official Statistics really got going in the last few years with the obvious aim of supporting and sharing experience across national statistics offices in using big data to drive and improve and strengthen official statistics, really supplementing the data sources of surveys, administrative data and others that we're well used to including and using as the basis for many of our analysis and our statistics. On the work over in 2017 in the UN Big Data Conference in, I think, Colombia, Bogota, we looked at how we could support and how the community could support some of the big data use that was going on, and really aim to support and accelerate this. And there the idea of a global platform was envisaged and discussed. And in 2018, this was endorsed at the UN Statistical Commission. So the UK's Office for National Statistics ran an 18-month pilot programme for the global platform, which we then handed over to Ronald Janssen and the United Nations Statistics Division group in July 20, with the explicit aim to then scale this for support for statistics work across the globe. So that's a really big starting point. And above all, the aim of the UN Global Platform is to support and enable use of big data in understanding the world. So improving and strengthening what we know about the economy and improving our statistics and our analysis on the economy, on society, on the environment. So some of those big challenges that all statistics offices and the global statistical community face in really understanding. And secondly, really understanding and improving and working at speed. So we know that many of the big data sources that are available, many from commercial sources and outside government and public sector, some of those sources can really give us fine-grained and highly temporal, highly up to speed, up to date understanding and knowledge and information. So there's a really great prize here. This is about improving and strengthening what we do and what we know about the world, and thereby improving and underpinning the big decisions that are being made. And I think clearly the last 12 months has absolutely shown us that. So that's the big ambition and the big aim for the platform. Under that, I think there are really three areas that I'd see and I'd highlight today that the platform is intending and aiming to support. The first is data. The use of some of the data sources that we're interested in that are from outside government, typically brought together, many of them in globe that cover the globe. And I'm thinking of the Earth observation data that Lorenzo will talk about. I'm thinking about the shipping AIS data that Jasper will talk about. Each of those sources brings something new, but they are explicitly global. And that's a really interesting challenge for us, because it's about making use of data sources that we have not designed, but data sources that we are acquiring and using and making available from others in order to improve our statistics. So that first piece is about making the data available and accessible for use and reuse by others across the statistical community. The second aim, I'm getting quite a lot of noise. I wonder if people could just go on mute. That's perfect, thank you. The second aim is around methods. And so many of the sources that we're interested in, the methods that we are using will not be the sort of traditional method that many of our statisticians and researchers will be familiar with. And so, for example, if we're talking about image data from satellites, Earth observation data, there are going to be a whole set of very interesting and quite challenging analysis methods, feature extraction, cleaning of that data in order to understand whether those sources can give us enough added power, enough explanatory power into our systems in order to improve what we know. So really bluntly, for an official statistic to incorporate certain data source, we really need to be clear on the value, the credibility and the quality of that data source. So those sorts of methods and the sorts of processing and the quality assessment is something that we'll all share. And so being able to reuse and share and compare those methods across the global community is absolutely critical. So that's the second area that the global platform aims to support, shared methods and shared experience in that way. The third really builds on this sharing and talks about the community. So we have a community of global statistics producers, the national statistics offices, many researchers in other institutions also looking at these data sources. The global platform brings a way of bringing together that community. And for example, under the global working group, the work of the task teams, which cover lots of areas, including the satellite imagery, Earth observation, including AIS, but also looking at broader aspects. So for example, commercial data as a whole, or capability and skills. Those task teams help bring together some of those communities, but also the platform gives a way of those communities sharing their experience, sharing their methods, and working on consistent, comparable data sources. So those are the three themes for me: data, methods, and sharing across the community. And the bottom line is national statistics offices face huge challenges. We have to understand the world, and we have to understand it rapidly and provide our analysis and our statistics in order to support decision making in almost real time. The demand, the pressure, and the need for our work has never been greater. So there's a huge value to assessing and incorporating big data sources into our work. And that's really where I think the platform can add huge value and can start to sort of drive some of the examples, or continue to drive the examples that we're going to hear about shortly. So I'll kind of wrap up there. I think that's my introductory pitch, if you like. The three special sessions that we're about to hear will talk about specific use cases that are working on the platform in very different areas of the world, in very different scenarios and sectors, and really with very different outputs. So I think they kind of illustrate the breadth of the work going on. So really looking forward to seeing how the questions from you all and the presentations. Before I hand over, I'd just like to make a couple of thank yous. And the first is, I would really like to thank members of the Global Working Group on Big Data and Official Statistics. So Rasenga Maluleki and Niels Plug, I've mentioned, the chair and the vice chair, but also Rob McClellan at the Statistics Canada, chair of the Technical Delivery Board for the platform. All the members of the Bureau and the task teams have really put in a huge stint on both how we improve and make use of big data, but also the platform and the work that's gone on to really help drive some of this forward. And the final one is I'd like to mention specifically Ronald Janssen for all of the work in supporting that group, and Ronald's team, not least for running this session. So Carolee and Catherine and Clarence and others, thank you very much. I'll probably hand over there. I think we're about a minute ahead of time. And just check that we've got everything lined up. Yes, brilliant. So I think that's me. So our first speaker, as I mentioned, is Lorenzo Di Simone, who's at the Office for the Chief Statistician in the Food and Agriculture Organization. We'll be talking on the UN Global Platform, a catalyst for the modernization of national statistics offices, the cases of Senegal and Uganda and the use of Earth observation for official agricultural statistics. So Lorenzo, I will hand over to you. Hopefully this will go smoothly and you can share your presentation and slides.
Okay, I'm sharing screen right now. Thank you, Tom. That you can see my screen?
Yes, we can see that perfectly, Lorenzo.
Okay, so thank you for introducing myself. So we save time on the presentation. And indeed, I'd like to provide you some narrative regarding the work that is being carried out in Senegal and Uganda, based on the collaboration between FAO through the Eostat Project and the UN Global Platform, as this combo is basically catalyzing the modernization process of the statistical system through the adoption of Earth observation for the production of official agricultural statistics. There is some noise in the background. Could you please mute your microphone? Thank you. So my presentation is going to very briefly review what is the relevance of crop mapping, provide a quick comparison between Earth observation methods versus traditional methods in agricultural statistics, highlight which are the common challenges in the adoption of Earth observation in national statistical offices, at least from our experience, and then provide small description of the Eostat project scope, some description of the Sen2Agri system, then the deployment of the Sen2Agri system on the UN Global Platform, and basically what is the role of the UN Global Platform as a catalyst, and finally provide some display of some results. So crop mapping on a seasonal basis can provide improved estimates of near real-time changes in crop production and can greatly benefit strategic planning in agroecological systems. The knowledge of spatial and temporal dynamics in crop growth and crop type distribution is crucial in many applications related to food security, land management, yield forecast, and prediction of commodity prices. So what is it in for Earth observation methods compared to traditional methods? So in this table, I'm comparing the traditional methods, for instance, surveys and agricultural census, with Earth observation according to 5 criteria: cost efficiency, disaggregation, timeliness, frequency, and sampling design. So clearly, traditional methods are less cost efficient than Earth observation. They're much more expensive. Disaggregation. So usually the traditional methods allow to national level data, whereas Earth observation is commonly used to provide sub-district aggregation level data. Usually the traditional methods, they provide the result after the field campaign and even up to 1 year later, whereas Earth observation can be used to actually provide forecasts or to provide seasonal estimates. So along the season, you can have more estimates. The frequency of the traditional methods, of course, is much lower than the frequency of the Earth observation data inflow. And finally, sampling design. So traditional methods typically rely on least point and methods, whereas Earth observation, you can optimally design the size of your data, because you can use it to create segmentation and then hence stratification based on various agroecological and socioeconomic criteria. So if Earth observation data is such an advantage, it's so convenient, why is it not so much frequently adopted in national statistics offices for the actual production of official agricultural statistics? So we found that there are several, of course, technical challenges, but there are also organizational challenges. So if I were to list the 4 most commonly encountered challenges, I would say the integration within existing workflows, the issue with in situ data, so the availability of this data, first of all, which is often required to calibrate and validate Earth observation products, and the concerns for data confidentiality from the data owner, so from the government, from the ministry who is in charge of the data. Third, Earth observation data comes with a huge volume of data, and this has a direct impact on storage and computation. And the higher the resolution of the satellite data, and exponentially your storage and consumption costs increase. Finally, the skills that are required, so Python coding, R coding, are quite advanced. So this makes it quite of a barrier, let's say, to adapt to this new technology. And here comes in the Eostat project of FAO. So the Eostat was conceived with the aim at building capacity in countries in the use of Earth observation to produce national statistics and support the process of modernization of agricultural statistical systems. And the spirit was actually to overcome those barriers by providing let's say, a self-packaged solution, which is easy to use, which does not require programming skills, which automatizes processes, and basically takes care of all the workflow from the Earth observation data input, the pre-processing, and the final results. As I will provide more explanation on the methods later. The system has now 3 pilots. So we have Senegal, Uganda, and also Afghanistan, which is just came in. The principal national counterparts in the project, in the countries, sorry, are respectively DAPSA, UBOS, and NICEA. The data pipeline and analysis is fully managed using the Send2Agri toolbox, which we will see facilitates a lot the work. And the solution is deployed on the UN global platform with a series of benefits, as I will show later. Finally, the project, of course, articulates a capacity building series of activities, aiming basically at providing specific training on 3 core areas. So the best practices in field survey data collection, hence the use of GPS for georeferencing crops in the field for the purpose of calibrating and validating Earth observation products. Crop classification theory, so supervised and unsupervised methods, pixel-based approach, object-based approach, and so on. And finally, actually hands-on use of Send2Agri toolbox in order to actually produce the so-called crop masks, crop type maps, and extract the statistics from there. And by the way, Cent2Agri is used only in Senegal and Uganda. For Afghanistan, we're experimenting a different approach. What is the Cent2Agri system in a nutshell? So the Cent2Agri system is an operational standalone processing system which is generating agricultural products from the Sentinel-2 data coming from a European Space Agency. And these products basically consist of a monthly cloud-free composite of the surface reflectance at 10-20 meters resolution, a monthly dynamic cropland mask, which is delivered from the agricultural mid-season onwards. So basically we are informed where are the crops being cropped at that time of the year. A cultivated crop type maps at 10 meters resolution for the main crop groups, which are delivered twice along the agricultural season. And finally, periodic vegetation status maps. So the NDVI, so the normalized difference vegetation index, and the leaf area index, which describe basically the vegetative development of crops each time a cloud-free observation is recorded. And the advantage of the Cent2Agri system can be synthesized in the fact that it is a free and open source software. It is maintained through project via the European Space Agency. It is built up upon a set of independent processing modules based on Orfeo Toolbox, which is very well known to the open source community on geospatial. There is an orchestrator, which is a central component which allows for the automatization of all the modules, so the execution of these components from the input Earth observation data, download through processing up to product delivery along the season, based upon the user supplied parameter. So this is very useful. And finally, there's a graphic user interface, which is designed to simplify the setting of mandatory parameters, for instance, site extent, season dates, and so on. And this, of course, facilitates a lot the work. This said, we come to the relationship between the Cent2Agri, the UN Global Platform, and actually the collaboration as a whole. So first of all, okay, Tom already explained what is the UN Global Platform. And of course, it's a collaboration network, but it's also, let's say, an environment where members are comfortable with software and engineering, and they aim to leverage this to build solutions for statistical community. In our case, basically, what UNGP could do for the project and was a game changer. First of all, it allowed us to build immediately trust with the ministry when we were supposed to propose the project, which involves the sharing of in situ data, so crop data. So first thing is the trust, the security. And secondly, the UNGP basically has built an infrastructure as a code that allows Cent2Agri to be deployed with minimal effort according to best practices in security and at a very low cost a low production cost and operational costs. It is used so both for the operational but also for the training. So it allows to generate training machine. Actually, this is happening in real time, as tomorrow we have the last training in the first session of the last training round in Senegal. So all of this together aims at lowering the barriers of the use of Cent2Agri and more in general of Earth observation within the NSOs. So results, I'd like to just provide a small overview of what has been reached so far. So as for Senegal, the Cent2Agri toolbox has been successfully deployed on UN platform. Historical in situ data has been gathered from the DAPSA and has been cleaned, basically. Prototype crop mask has already been produced for the period April through December 2020. And 2 webinars have been delivered, one on the field work and another one on Cent2Agri toolbox. And the next steps, so for the first 2 quarters of 2021, and that will be the project completion, we will produce the crop type map, we will calculate crop acreage and crop yield statistics, and then we will deliver the 3rd webinar, this is happening this week, as I said, on the actual computation of the crop mask and the crop type map. Just to provide a quick look into the data. So you see all those dots, those are the in situ data that we have acquired and cleaned from the Ministry of Agriculture. And as you can see, they are found in almost all of the agroecological zones in Senegal, which are colored are those colored polygons, those patches. And for the time being, basically, we are now in the phase of where we have calculated the crop mask. So I will just show you what a crop mask looks like. Okay. So this area in green basically is discriminating where we have crops and where we don't have crops. And so basically we have this for the entire country along the season. And this of course allows you to extract the crop acreage and subsequently to support the discrimination between the different crops. Going back to the presentation, I also have some snapshots furthermore of the crop mask. This is just a subset of the crop mask, and you can see how it looks like. It's really a binary map. Some further details, just to highlight how it accurately managed to identify areas of crops. Uganda. So results for the Uganda project. Essentially, we are a bit behind because COVID impacted quite significantly this project. So we managed to resume the activities in late October. We deployed an ad hoc field survey protocol, and actually we delivered also the training in the field so that ad hoc data could be collected, as we need this data to train the algorithm within the Send2Agri toolbox. So what we see for the next 2 quarters is basically the production of the crop mask and the crop type map, the extraction of crop acreage statistics and crop yield, and the hands-on webinar covering basically essentially the Send2Agri, the theory behind the algorithms, and the hands-on practices. And I would just like to take this opportunity to show to you how the survey has been basically deployed. So we have identified a series of enumeration areas within 2 specific agroecological zones of Uganda. So we are limited a bit in the geographic scope because of COVID. And if we just select one of the enumeration area, like any of those, you can see that, sorry. So for each enumeration area, basically we have a cluster of 9 we have 9 clusters basically for each enumeration area. In each cluster is made by it's composed by 9 points, which are 1 kilometer distance from each other. And our survey teams, so basically we have 2 survey teams. Basically they address each enumeration areas, and in half a day, let's say 1 enumeration area can be covered by one team. And for each site, of course, we collect the crop type and the coordinates and any other information if they are available on the management of the crops. Going back to the presentation, I think I have my last slide on Afghanistan. I just want to check if I am within the time. Okay, so in Afghanistan, more or less, we are at the same speed with Senegal. So we managed to gather in situ data from the national statistical offices, which was much less data. Reason for we had to change a bit the algorithm. So we have developed already an algorithm for the crop mask. We have produced currently the crop mask, which is being now validated. And we also have produced a crop seasonality map, which basically allows us to identify within the crop mask those areas where the crops reach the peak of the vegetation in the first half of the year, or those ones that reach the peak at the middle of the year, and those ones where we have 2 peaks during the year. So it means that there is a double cropping. The next steps, so in the next year, so until December 2021, is that of benchmarking now the classification algorithms to create the crop type maps. The actually development of the crop type map, apologies, that's not mask, it's map. And then the calculation of crop acreage and crop yield statistics. And of course, the strong training component. As I did for the previous project, I would just like to show a bit of the data, the real data, let's say. So those are the sites where we obtained some data. We only had data for wheat and for rice for the time being. There should be another small data collection just for cotton, which should soon take action. And based on this, we managed basically to first calculate the growth degrees days for the entire country, which we used as a stratification layer together with spectral features. And as a final result, we managed to produce the crop mask for 2020. So this mask essentially discriminates, as we saw before, for Senegal. Just a moment for refreshing. It basically allows us to identify cropped areas from areas that are not cropped. We did quite a good job, I have to say. As you see, it's very, very quite detailed. So we're quite happy with the work. And on top of this, as I anticipated, we managed to calculate also to map the seasonality, which as I said, it means to know if the crops within the crop mask basically reach the peak, when do they reach the peak during the year, and if they have two peaks. This is very informative, of course, because it will facilitate the discrimination now between crop types within the crop mask. And I think this is all from my side. I hope I stayed within the allotted time. So,
Lorenzo, that was absolutely perfect timing, and thank you very much. So we have a few minutes for questions and answers. So please do put your questions either in the chat, or if you would like to come in and ask directly, then put your hand up. There is one coming from Daniel Eschetti. Apologies if I have mispronounced your name. Lorenzo, I don't know if you can see the chat, so I'll read out. Is there a plan to scale this work to additional countries? As cost is a barrier to entry in most NSOs, is the provision for providing the satellite images used as an input at lower cost or for free?
So this is a very nice and to the point question. Indeed, the idea here was to combine the forces of UN Global Platform and the Office of the Statistician in FAO, so that on one side we can ensure a standardization of the methods, of the algorithms, of the accuracy measures, and on the other side we could find support and a solution to scale up. So the work that Sean has done brilliantly was that of developing actually a technical solution that allows to scale up to more countries. And of course, there are costs associated with this. And part of the work of the engineering cost is also to minimize those costs. So we also learned this by doing, according to where you put your data, which type of setting you utilize, you can minimize your costs. So there will always be some costs incurring for the use of commercial cloud products. And I think that's a bit the call of the organization to create projects, basically, which can support those costs.
Many thanks, Lorenzo. Daniel, I don't know if you wanted to come back in. I'm looking for hands. Ronald, you have a question.
Thank you. Yes, and I fully agree, Tom. Thank you, Lorenzo. Very, very nice presentation. Oh, I see that I'm sort of on the screen. So thank you for this. Yeah. So briefly on the last question is that yeah, we have the UN Global Platform. I'm with the United Nations Statistics Division. We're supporting the platform. We have this as a community platform for the whole statistical community. So we try to support countries in the developing countries, statistical offices there in this kind of work. I have a question to you on this, Lorenzo. It is in relation to, as you indicated in the first slide, we could do this high frequency, right? And I think you've done this like on a monthly basis for Senegal in 2020. And if I'm correct, you also did some of that in 2019, month by month. What does this mean for the in situ data, right? So you and the calibration of month by month. How just briefly, I don't want to go into all the technical details, but just to indicate that with this satellite data being available, you can run this quite frequently see the growth patterns, and that's, I think, a huge advantage. On the one hand, a huge advantage over current surveys, and the other thing is that the let's say the power of this platform allows us to actually do this. To you, Lorenzo.
Okay, so if I understand well the question, so the question is, if we have this production regularly, could this be run like in the next years, like by practice, in a kind of operational environment? Is this the question?
No, actually, the question was your in situ data. You probably take that once.
Yes.
Your
Okay.
With the satellite data, you can run this on many months. At what point are you recalibrating?
Okay. Good. Okay, so of course, given the type of approach we use for Senegal and Uganda, where we use a random forest approach, this is designed to work on a yearly basis. So, and it's supposed to be supported by field data collection on a yearly basis. So once you have your yearly data, which doesn't need to be so much as abundant as a regular agricultural survey, of course, it has to be just representative of the various crops within the different agroecological zone, then you run with that for all the year. So you get your crop masks being developed along the season, because you will see that new fields are being cropped, other fields are being left, harvested and so on. So you see how this evolves. And then, of course, if you want to transfer that to the other years, then you need to start to use different type of algorithms, of probably, which are more data frugal, which is what we are experimenting in Afghanistan, because so far, research tells us that the random forest is the most robust one, and of course, it's data intensive. Regarding the work of processing the images on a yearly basis, you want to basically have your pre-processed data, which is clean from clouds, from cloud shadows, and so on. So unfortunately, that you have to do as new data comes in. So independent of which approach you're going to use, as you're going to analyze the phenology of your plants, you need to have regular images, and somehow you need to basically find a way to interpolate your values when you have clouds. So you're always going to have to do that independently if your classifier is more or less data, let's say, hungry. I hope I replied.
Thank you very much.
Lorenzo, thank you. There's a couple of questions in the chat from BPS Indonesia and some responses from Sean at UNSD. But Gordon Reichart, I think you have your hand up as well. So over to you for your question.
Thank you. Lorenzo, a quick question. With respect to the in situ data that you're collecting, is it considered confidential? If it is, how is it then you're able to use it on the cloud? I'm assuming it's an open cloud, or is it a protected cloud? If it's not confidential, then my question is a moot question.
Okay, so the data per se provided by the DAPSA is confidential and is only shared on the UN global platform for the purpose of the project. Now, using our skills in creating confounders within the data, once we have the crop type maps, what we're going to do, we're going to generate synthetic in situ data, which basically does not allow you anymore to link to the farmer. And then we can use that as an open data set for scientists who want to train their own algorithms, so you can foster collaboration. So we are still in a phase, let's say, where we cannot share, of course, the core data set. And so we have a signed agreement with that. But of course, when the project, let's say, has been designed, it is agreed that this data go into the UN global platform in an environment which is not public available, but is just available to the ministry who is interested in building this internal capacity. So there are, let's say, two streams of work, let's say, in order to make this data shareable.
Lorenzo, thank you for that. I think we're running short on time for the Q&A stage, but I really want to thank Lorenzo for the talk and for the question answering. One of the challenges when we're talking about big data, we know that there is potential for faster and finer grained information to feed into our analysis and our work. But what I think came over really clearly here was the work that Lorenzo and the team have done around looking at quality and checking back in. And that's one of the big thresholds that we know we have to clear with any data source, and some of the big data sources are no different. So I really welcome that work as well. And that was great to see the approach taken. Finally, I just want to kind of, maybe if we could try this, if we could thank Lorenzo. I don't know if you can all come off mute and clap for a few seconds to show our appreciation in the old-fashioned way. But thank you very much, Lorenzo. Thank you. Now, before we go on to our next speaker, I think I've seen Stefan Schweinfest join us. Stefan is the director of the UN Statistics Division. I know that, Stefan, you've been very involved in the thinking around the UN Global Platform, and I wondered whether you wanted to come in either now or in the next slot just to say a couple of words about the thinking and the ideas around how this supports the UN global community and the statistics work across all of the NSOs. So if you're still on and have a couple of moments just to talk on us through some of the thinking and the work there, I think people would find that very interesting to see how this fits into the bigger picture and the perspective.
No, thank you very much, Tom. Yeah, I'm here. I hope you can hear me, Stefan. I'm indulging in my favorite activity these days. There are all these new words that are invented. I'm platform hopping. I'm going from one event to the other. And so I just wanted to, I was a little bit late, but I heard part of the presentation and I'm very excited. First of all, I want to go back to the very roots. I mean, our working group is entitled Big Data for Official Statistics. So it was always with the perspective, how can this new universe of data and tools help us to do our old-fashioned traditional job of producing official statistics, which are always the backbone of any information system for any country better. And of course, we have the National Statistical Office as an institution in the centerpiece that has a new role with its data stewardship these days. And also, I mean, the evaluating new and exciting data sources. So I think we have been ahead of the curve because many people come now with these ideas. And I always say, please check our notebooks. We have had a big data working group in the Statistical Commission since 2013. So I think in the bigger picture, we were ahead of the curve. We still are ahead of the curve. I'm very grateful to all the people who are contributing to this event. ONS and the UK has, of course, made a specific investment in this area, and I'm thankful to you and your leadership and your colleagues in the ONS. I'm also thankful to the countries that are working with us. There is a little bit of a brave pioneer spirit here, Senegal and Cambodia. So I think it's also an important proof of concept that these things are not just things for very advanced countries. On the contrary, I think some of the very basic tools that we are discovering and developing and refining here are really helping those who need most an additional injection on data and catching up with their data gaps when it comes, for instance, to SDG, Sustainable Development Goal reporting. So this is all a very exciting project. I don't want to take up too much time. I just wanted to plead to everybody to stay with us because the global platform is a completely new endeavor. It is a collaborative approach, trans-borders. It has its scary elements. I mean, already in the last questions, there came up some elements of data confidentiality. How do we move data across borders? How can we do it safely? And those are all very legitimate questions. What is the IT technology behind that supports us? So the global platform, with its fundamental idea of having data, tools, and training, is a very exciting idea. But we need to keep on the ball, working all together, making the case for it. And I need to still find some more sustainable funding for it. I will admit this here publicly. So if anybody has excess money, you can always call me. But when I say we need resources to do this, I'm also not always only talking about Donald Duck and dollar signs. Resources are also human resources, intellectual resources, knowledge resources. So everybody who is here today as a speaker or one of the participants in one of the projects is contributing to this. And I really wouldn't want to lose this opportunity, miss this opportunity to thank everybody and really say, let's take this ship forward. I'm very much looking forward to the next steps. Thank you very much.
Stefan, many thanks for that. And folks, for all of you listening, the note on support and input greatly welcomed. So please do feed back into Stefan or the Global Working Group and so on for the next stages. Stefan made a very nice segue, a link into the next speaker. He mentioned ships. So I'm delighted to introduce Jasper Verschoor at the Environmental Change Institute at the University of Oxford, who will be presenting on deriving real-time maritime transport statistics using the automatic identification system, the AIS data. So Jasper, I hope that you're able to share your screen from where you are, and perfect timing. Over to you.
Thank you, Tom, for the introduction. And thank you, Stefan, for setting the scene and putting a bit of pressure on my shoulders here. So as Tom said, I will discuss part of my research as a PhD student at the University of Oxford on using the automatic identification system to use or to derive real-time transport statistics. And before starting, I want to thank the AAS task team beforehand, especially Mark, who's leading the team, because it's a huge collaboration, a lot of people involved, and without anyone, I would have been here. So yeah, many thanks before I start. So let's see if this works. Bit of an outline. So I start briefly explaining what the AES data is, how do we process it on the UN global platform, and I will discuss a few applications on estimating port calls, deriving regional maritime transport networks, and estimating maritime trade flows. And I also conclude with some of the challenges and take-home messages of the data. So to start with, I think many of you have seen these kind of beautiful figures of the world with all kind of the density maps of where vessels are going. And in fact, these maps are usually derived using the automatic identification system of AES data, which is, in short, tracking systems of global maritime ships, which was originally introduced by the IMO to prevent collisions on sea and in port areas, but very soon became useful for all kind of other purposes. Why is this the case? Because it includes the information of the vessel location, its speed, its status, and all kind of other static information on vessels, such as what type of vessel is it. This information is transmitted every few seconds using very high frequency radios. And in the figure below, you can really see how this goes. So you have a AES vessel that has an AES transceiver or responder, which sends its signal to a terrestrial receiver or a satellite, which processes the data, decodes it, sends it to a data store, and this data can then be used in almost real time by the AES data user. So, as I said, there are many use cases nowadays, and these are some of the things that I find very exciting is, for instance, monitoring fisheries, including illegal fisheries, and this is a paper in the top from that was recently published on mapping illegal fisheries in South Korea. That's been used to look at the vessel activity in marine protected areas, look at invasive species, the risk of oil spills, and also on estimating vessel emissions. And this is a map showing another research where they looked at every individual vessel and estimated how much SO2 emissions came from that vessel. And the last thing is on the use case of using it to estimate trade indicators, and that's what I will discuss today. So briefly on the UN global platform. So basically, as I say, all the data is being processed. It's received and stored on a online server from which we, the AES users, can extract the information that we need. So to give you two examples, we can, for instance, extract data for a particular port in the bottom figure, where I looked at what is the vessel locations for a week of time in the port of Dar es Salaam. And you get all kind of like movement of vessels. Or we can say we're interested in one particular vessel and look at its movement over a longer period of time. And that's what you see in the top figure, where I said, okay, I want to track this particular vessel because I know it's serving some of the Pacific islands, but how does it actually do that? What kind of ports does it visit for over the course of a year? And then you can add all kind of filtering criteria, such as I only want to look at certain types of vessels. I only want to look at vessels that are moored or actually in motion. Because there are some considerations here. As Lorenzo also mentioned, these data sources are very big. So you have to kind of think about what is my purpose, what is the minimum data requirement that I need, and can I make it manageable to work with also if you want to bring the data to your own computer. So talking about maritime trade indicators, so why we think this is important is that maritime trade or transport is an important economic indicator, and needless to say, maritime trade contributes to the majority of trade in goods globally. And usually we always tend to look at official trade statistics, such as those provided by the UN, which have a few drawbacks. First of all, there's often a significant lack in reporting, sometimes months to years. It's highly aggregated data, yearly data, sometimes monthly, and it's tend to be biased toward high-income countries where we do not always know what is going on in lower-income countries or small islands. So in some cases, we are more interested in these high spatial and temporal resolution trade indicators, such as to nowcast the economy, understand the dynamics of trade over time, such as during COVID, or being able to track trade in low and middle income countries because we lack the data. And the question we posed was, can AES support us in achieving this? So I started at the basics and looking at port calls, because this is the kind of the easiest use case of AES data. And what we do is we define a certain port boundary and we track the movement of vessels going in and out of port. And using this, we can sort of define when does this movement of vessels constitute a port call, and then we can sort of do different things with it. So I show you a few things that we've done with this. So first of all, by aggregating these port calls on a daily time scale, we can say, look at individual ports and say, what is their operational status at any moment? And this is something we did in the project that you can see below, where we looked at the operational status of the port of Houston during a hurricane, in this case Hurricane Harvey in 2017, where you can clearly see that this port was shut down and then had to recover a few days before it went back to normal operations. And this gives us very valuable insight in the operational status of ports. Then we also looked with a project with the IMF on, can we see what's going on in a very small island, let's say the island of Samoa, where we have good official statistics for port calls. And we realized we could come to an almost exact match for a two-year time frame for this island, which showcased to us that this data can actually be used in a variety of countries. And the third project was to say, okay, if we can do this, can we then scale it up to global scale? And this is something we did with the UN, and we developed the kind of AES port call monitor, where you can go to this website, you can click on a country and click on a week, and you can see how many vessels go into this different ports in a country, and you can compare their status in 2020 compared to their status in 2019. So the second thing is, can we track the movement of vessels or number of vessels over time to construct a certain maritime transport network? And instead of port level indicators, we can get insight into the kind of maritime transport routes. Because this is data that's usually not available. So what we did is we followed the movements for 130 vessels serving Pacific islands over time, we constructed a maritime transport network, and you can see them in the figures below. And a network here is basically how much trade goes in between two specific ports. And this is work in progress, so the pictures are not very pretty. And it's hard to see if there's any change, but if you then go to the top figure and you see that, and you realize there is actually some changes going on, and the red lines are actually drop in trade, whereas the green lines are an increase in trade. So without looking into the specifics of it, you can see that the maritime transport network has been restructured, and this could be because of COVID. This could be because of other reasons, and this is still work in progress, but just to showcase that these kind of applications are also possible. Then maybe the most exciting thing is if we know that port or vessels went into a port and that they might have dropped off or taken on some cargo load, can we also use it to estimate how much trade actually went in and out of ports? And the next step, if we know what type of vessels went in and out of port, can we use it to say what economic sector did this trade contribute to? And if all these answers are yes, then we can answer questions like, or we can look at purposes such as high frequency trade estimates on like a daily or a weekly scale. And this is what we did here. And I don't have time to go into specific, but we looked at a certain number of countries when the COVID situation evolved and asked ourselves, can we see the impact of lockdown measures in the AES data very clearly? And the answer is yes, but things are actually a bit more complicated in reality than we initially thought, because we can, for instance, see the demand and supply shock in Malaysia and Australia because of lockdown measures initiated in China. Similar for Vietnam, we saw initial decline, but then in Vietnam something interesting happened where there's actually a very large increase in the amount of maritime trade, which seems to correspond to some indicators that some production has been taking over in Vietnam during the early stages of COVID. Then in the figure on the bottom on the left, we looked at 3 different countries that initiated lockdown measures in a similar period of time. But as you can see in the circle, the trade data responds in a kind of different way. Some trade statistics respond very quickly, such as in South Africa, whereas in USA, the trade data responds more in a lagged manner. And yeah, just to kind of highlight that things are a bit more complex than initially predicted. And I don't have time to go into this, but then the next question we ask, if we can monitor trade on a country level, we can also do that on a port level. And here we tracked basically the maritime trade flows going in and out of ports during the whole first 8 months of the pandemic, and derived kind of monthly indicators whether trade was going increasing or decreasing in this port. And there are all kind of lessons we can learn from this. So the second thing that I want to highlight is, can we better map sectoral trade flows on this high frequency scale? Because we know that different sectors might respond very differently, and they have very different dynamics. So this is a map or a figure showing the different economic sectors over time during the first 8 months of the pandemic outbreak. And you can directly see that there are different time series have different dynamics. And just to highlight, in sector 10, for instance, which is the vehicle and transport manufacturing sector, you can clearly see that this one is hardest hit during the pandemic. And this also reiterates some of the statement has been made on these global supply chain shocks, especially in this economic sector. And this is also very briefly something that's a bit more of a scientific exercise, where we ask ourselves, okay, the AES data is great. It offers us a whole new, all kind of new questions we can ask, but we're not really sure how accurate it is in all kind of levels. So can we come up with some sort of hybrid approach where we say, okay, on a country-to-country level, we know the trade flows from official statistics. We can estimate using a certain method how what percentage of this trade between countries was maritime, but then can we use the AES data to predict which ports were actually being used to transport this trade between countries? And this is what we did here to create some sort of hybrid downscaling approach to use the AES data and predict where trade goes in and out of ports and how does it differ between economic sectors, which is shown in the bottom smaller global maps. So to wrap up, the challenges, so AES data, it's a lot of data. The raw data can be up to multiple terabytes. So it's good to ask the question, what data do you need exactly? Do you need all vessels? Do you need only a few? Do you want 2 whole years? Do you only need a month? There are still some errors involved with the data. So there's manual input and there are just general errors. And it could be that data is wrongly inputted, that there's wrong locations. So data cleaning is a very hard and difficult task. So the third point, port calls are easy to derive and very useful, but if we go a step further and think about estimating trade flows, it becomes already a bit more troublesome. And we have, from our results, we see very mixed results between countries. And then the take-home messages, there's a lot of opportunities with the data. You can go from local to global, look at different timescales, various end users, governments, international organizations, or port authorities. And in our experience, this kind of hybrid approach that we're now testing is really the way forward to kind of combine official data with this experimental data. And I would like to conclude. I think I'm running a bit over time, so I'm sorry for that. But yeah, that was the talk, and I'm happy to take any questions.
Jasper, thank you. I mean, super interesting and very happy for you to run over a little bit. Questions? I haven't seen anything coming through in the chat. Are there any hands up? There's me. Great. Do we have any questions? I saw a hand go up, but I can't see anything now. I mean, while people are coming up with thoughts and questions, and please do add them in the chat otherwise, I have one, Jasper. Really interesting to see the exploration and the research that you're doing and how this is supported by the platform and the data source. I wonder whether you could say something about your thoughts of developing statistics and analysis over time. And this is one of the questions that we have with a big data source, where it's generated by processes that are not within the statistical office control. So something about how stable you see this as a source of information, and what we would need to do to keep track of changes over time in what I might describe as the processes that generate the data.
Yeah, and that's a very good question. And I've had discussion with Mark, he was leading the AES task team, on exactly this, because like we need to emphasize that this is experimental data, and we're trying to validate it in as many countries where we have data and where we can validate this, but this just cannot be done, and because the results are different between countries, and we know there are issues with, let's say, countries with very high trade imbalances where the data has just more difficulties to get accurate results. When we were initially developing this global port call monitoring system, we were thinking of doing the same thing with these trade estimates, but then we thought it was very hard to make clear that this was experimental data. People might use it and think this is the actual true data from statistical agencies, which is not, and might make decisions based on it, which might not be grounded in good solid data. So yeah, it's a good question, and I think the use of these experimental indicators is increasing, and people start to understand them and leverage them in very useful ways. But we need to be very careful on what we can do with that and what we cannot do with it.
Great, thank you, Jasper. We have a question in the chat from Harpal Shergill. Did you try looking at other data sources along with AIS, or is this AIS data only?
So there are some algorithms behind this, and we've validated these algorithms based on official port level trade estimates, country trade estimates, just to see how well the data is performing. There is obviously the things that I've presented on, let's say, the first 8 months of COVID. This is done a while back, and now we can actually maybe go to some of the official data and know in much more accurate way what was actually going on. But yeah, it was just to showcase that during these type of periods where everyone wants to know what's going on, these experimental data can actually inform us in almost real time and help us understand and also potentially prioritize or allocate funds to countries that we see are hardest hit by the pandemic.
Thank you. Ronald, I think you have a question.
Yes, thank you, Jasper. Again, a very exciting research work that you do. Two questions. One is in connection with the question just asked is what's your wish list for additional data that you need? I know that the International Maritime Organization made some ship register data available, and so what do you see that you can do with that? And what other kinds of data would really improve your work? I mean, if we start reaching out to customs officers trying to get bill of lading kind of information online and things like that. So just your view on that, that's one. And the second one is you work for the Environmental Change Institute. Are you doing also work on the greenhouse gas emissions? We know that's work that's done quite a bit now under the IMO, the International Maritime Organization. Also want to see if Oxford is also involved in that work. Thanks.
Yeah, on the data wish list, do you have a moment? No, there's good data out there, and as you say, the vessel registry, that will be a very valuable addition, because we actually acquired this data ourselves to use it, and this was like for us really the thing we needed to make the step also towards trade estimates. But how can we improve this data? Yeah, validation data, that's just the key. And I think that's going to be the key in a lot of these big data projects, where doing things and doing nice statistics on a country level or for a few countries is great and can be done if data is available. But then taking this step to extrapolate things to other countries, to other continents, and on a global scale, that's really the tricky bit, and we're doing our best to see or provide some sort of indication of what is the error term, but it's just very hard to estimate also with this data source. And on the the research side, so initially we wanted this data to actually do the last thing that I showed, to understand how trade flows go between ports, because my research is actually on climate risk analysis to ports, because we want to understand how ports or trade flows are actually going through ports and being used in the economy, and connecting the maritime trade flows on a port level to the national input-output tables of countries, and being able to say, okay, if a port is out of servers, if it's disrupted by a natural disaster or a climate extreme, what are the potential macroeconomic losses? And this is kind of our perspective of where we wanted to use the data for. But when I got involved a bit more than a year ago now, we saw all kind of like potential with this, and also because of all the ideas floating around in the AAS, the task team. So yeah, it's we are not working on the emission question, but yeah, there are great people out there that do this.
Excellent, Jasper, thank you. I think we have time. One more question. I can see that Setia and BPS Indonesia have your hand up for a while. Your floor is yours.
Okay, Tom, thank you very much for my time. It's great presentation, Jasper. One quick question. I tried to access our team tried to access the ICE data from Google platform, but it turned out that the system is a bit slow, so we cannot get the data directly right now. Is there any ways that we can have the access or any to speed the access of the data so we can start to analyze the data? Thank you very much.
Yeah, yeah, that's a good point. Yeah, the AES global platform is used by a lot of users at the moment, which means that you cannot just do simply very big requests. You have to be a bit smart and understanding how does it work, how can I do very efficient queries on the platform. And there are great people to help you with that. So if you reach out to the people that help maintain this server and the platform, they can help you with structuring your queries and making it more efficient. But yeah, in the meantime, yeah, also on your point, Tom, on the data sharing, we're also, we're very open to share everything we have. So we're almost at the moment, I'm trying to make all my ports call data, my trade estimates, everything publicly available for organizations or researchers to use. So that's yeah. So if you want to send me an email, I'm happy to send you the port call data if that's useful for Indonesia, for instance.
Great, thank you, Jesper.
Great, thank you very much. Yes,
excellent.
Thanks.
And so I wonder if UNSD folk on the call could also give a bit more detail about in the chat on the thinking around how the AIS data and the processing and so on can be opened up. So that sort of and that kind of challenge, which is a result of the level of use of the AIS data and the value of that data to lots of different research questions. Great. I think we're out of time for Q&A here, and I really want to go on to the next and final speakers, but maybe we could thank Jesper again in the same way. So thank you very much for an excellent presentation. Great. So our third and final presentation is by Sean Lovell and Abdullah Gozalev at the UN Statistics Division, and they will be talking on Cambodia's national database, CamStat, and successful implementation of the .stat data warehouse on the UN global platform. So Sean and Abdullah, over to you.
Thanks a lot. So I'm going to let Abdullah start this. We sort of split up the presentation in a nice, concise way. So our presentation is on the entire process of migrating data from CamStat's original instance to the global platform, which is a long story. But Abdullah, over to you.
Yeah, thanks very much, Sean. Good morning, good afternoon, everyone. Thanks for attending this event. Okay, so we don't have a lot of time, so I'll try to be brief. UNSD has cooperated and has supported the Cambodian National Institute of Statistics for as part of our capacity development projects for quite some time. Cambodia has used the DAVINFO database since 2004. DAVINFO was the project supported by UNICEF, which helped many countries establish their first statistical databases initially, and then their first web-based statistical dissemination of statistical data. So it was very widely used during the MDG era, as it was primarily designed in support of the MDGs, but it was not, its scope was not limited to the MDGs. It's a general purpose data dissemination platform, and it was used for disseminating a broad range of statistics. However, as the MDG era neared its end, so did the support for provided by UNICEF for DAVINFO. And by 2015, 2016, 17, the question arose of what was going to replace DAVINFO. Next slide, Sean, please. All right, so UNICEF came out with an initiative to pilot the transition from DAVINFO to the .stat platform. essentially to replace Devinfo with a .stat. .stat is software platform for statistical dissemination developed by a community led by OECD. And so in 2018, the project started on trying to migrate Devinfo to .stat. And this migration involved deploying the new database required several types of effort. One was migrating the data in structures. Devinfo was proprietary, used proprietary format for both, and extracting the data and making it interoperable did require a major effort. And once that has been done, and once data is in an interoperable format, namely SDMX, then the question is how to deploy .stat, how to offer it to Cambodia, whether it was going to be run locally or as software as a service that is based in the cloud. So UNICEF initiated the project in 2018, and it has worked closely together with other international agencies, UNSD, of course, but also OECD, which leads the consortium Paris 21, which did a lot of work on assessing the data flows, UNESCAP that supported the NAS as well, UNFPA in Cambodia office, and others. And so this is a really successful example of agency collaboration. Go ahead, John, please. Okay. So the original ComInfo database, that is Cambodia's implementation of Devinfo, it was one of the largest Devinfo databases in the world, and it had over 50 data sets and over 160,000 observations. UNICEF led the effort on data migration and worked with obviously with the NAS as well as partners. UNICEF put in a lot of effort to automatically migrate the infrastructures and data into SDMX. I think one of the biggest issues was that the data was messy and required extensive cleanup, but thanks to automated scripts, this was achieved. At the same time, new data sets also had to be created because obviously the world doesn't stand in place, and in particular the SDG, as the SDG was starting, UNSD supported the NAS in creating its SDG data sets, structures, and data, and establishing the data exchange as part of the UNSD FCDO project on SDG monitoring. And even in the early stages, a pilot data exchange was established with the SDG global platform. So at the end of this effort, what we had by 2019 was a platform running in a test environment supported by UNICEF and OECD. And this was already out there. This was already for public use. And the government of Cambodia designated CamStat, this new database, as its official data dissemination platform during a ministerial meeting, which was, of course, a major achievement. However, there was still, at that time, there was still no sustainable long-term setup for hosting the .stat platform. And until that was solved, all sorts of issues remained, for example, country ownership and long-term sustainability of the project. And after discussing several options, including going through commercial providers, about a year ago, a decision was made to deploy the .stat platform on the UN Global Platform. And now I turn over to Sean, who will continue. Sean, you're muted.
Thanks. Is that better? Can you hear me? Okay, awesome. Great. No, so I'm Sean. I work with Ronald and others on the UN Global Platform. I'm more on the technical engineering side. but I was a statistician in a prior life. So this story, I think, picks up from the global platform perspective in the spring of 2020. So there, at some point, we were approached to migrate the infrastructure that underpins this sort of already christened CAMSTAT database to something of a more permanent home. Either, in terms of, and for us, this was twofold. It meant finding a quick solution to make sure that we didn't, have a shutdown of a service because of lack of funding. But it also meant that we had to look at tackling some of the fundamental challenges that made .stat hard to deploy, at least from our perspective, so that we felt comfortable that this is a solution that was easy to deploy for us, in which case maybe easy to deploy for others. So it's in early 2020. The pandemic is starting. Of course, the global platform team is already remote at that time, so that was a valuable advantage I think that we had. We weren't tied to to VPNs that were specific to UN infrastructure, so we had a lot of flexibility in how we designed the solution. So the challenge as it was presented to us was to, as we discussed, deploy the actual software itself and transfer all SDMX data structures, which were already basically converted from a proprietary format to this interoperable SDMX format, but we had to move those to the new instance, a small data migration aspect. But we also wanted to make sure that this was a repeatable process in the sense that the platform could support multiple tenants. So if we did the work once, we'd like to be able to accommodate additional countries who would also like to use .stat to use as a front end for data dissemination. So that meant it had to be easy, reproducible, and also just from an IT ops perspective, we wanted to make sure that the entire thing was scalable, reliable, maintainable, and secure. There's no sense in having a solution if it's easily hacked and doesn't scale well. So these were all sort of fundamental considerations that we had. So we took a look at it. First glance, deploying .stat for new tenant. It did appear to be quite a daunting challenge for us. So it's a distributed system of 12 interdependent services, including databases, caching, and a search engine. A lot of microservices there. It's written in .NET with JavaScript front end. So all of these things were interdependent, and they required careful system configuration. So it was a learning curve for us, to be sure. So just to give you an overview of .stat, which is it's a really well-built solution. So we're really happy to work with it. But it did have this sort of deployability challenge when we touched it for the first time. I think this is the problem space we're entering in. So configuring and restoring a distributed system consisting of many interdependent services can be a challenge. I think hopefully that's clear. But we didn't have to start from scratch. And so we had a lot of support, both from the work that had already been done by UNICEF and OECD, as well as support from the .stat community, which helped us really, get a grasp of this issue of configuring the services. So the starting point for us, we decided to look at the use of containers because UNICEF had worked with the OECD to develop containers for the various .stat services. So this approach helped us in the sense that we didn't have to configure dependencies for each of the individual services. We could use the dependency package with the software, and this would minimize that aspect of configuration. So that's a benefit, but it also meant that we had to really think about using a modern container orchestration approach. So, there are different approaches to this. We had a discussion with the people on the team. I'll mention who they were in a bit. But we went with Kubernetes because it's the most modern and robust solution. And the advantage of that is that it's a declarative approach. So the entire solution, instead of thinking of it like you're soldering these pieces in place and sort of a lot of manual configuration, we could actually put the entire solution into a code base, which meant that if the whole thing went down, redeploying it from scratch would be relatively simple. It wouldn't take us weeks or months to put back together, which was important because we're short. We don't have a lot of people on the team. So that was a strong advantage. That meant that we did some disaster recovery simulations. We were able to get the thing back up in about 4 hours. from some of the most catastrophic scenarios. On average, it's actually much less than that. So it also has a fail-safe mechanism. So Kubernetes will automatically restart services that die because of resource, out of resource limits and this sort of thing. It automatically scales, and it has this idea of zero downtime deployment. So you can have, a development instance, when it's ready, you can, pass over traffic to that instance, and the, end user doesn't see anything. So there's no email on Saturday saying you have to not use it for an hour or something like that. So we did manage several Kubernetes clusters for our services, so this was a natural approach. So I don't want to go too much into the details, but that's really what this is about. So the way we tackled this was by starting from the bottom and working our way up. And I think that's a good analogy for how the chief architect from CBS Netherlands, Peter Zandbergen, approached this challenge. So what happened when we worked on it, I want to start out that we started by reaching out to others who had done similar things. So we talked to people at ESCAP and a lot of other people. Finally, we were lucky enough to work with CBS Netherlands, who provided a very excellent technical expert to work with us, who has a security background, who could really fill in the gaps that we didn't have on our own team. So, and this is, I feel, one of the benefits of the global platform network itself. So we started by trying to develop the Kubernetes resource definition files for the most basic elements first. So starting with the databases, those things that didn't have any dependencies, and then moving up the dependency graph, if you will. So starting with a database, and then starting with a service that uses the database, and then exposing that service and making sure that the functionality is working. So that was the iterative approach that we took. And through that, we would configure each of these deployment files. And eventually, several months later, or about a month later, Peter got to a point where he had a hello world deployment of .stat on his local machine. And this got us really in a good place, because with Kubernetes, if it runs on your local machine, you can run on the cloud. It doesn't make a difference. It's very easy to transfer. So it's not sort of stuck in one cloud provider, if you will. So finally, we took a few, but he improved it. We decided to move to managed AWS databases, so that if there was a catastrophic event, that the data wouldn't be lost. We'd have backups that would automatically be managed. We wouldn't have to deal with licenses. So these are all things that we have to consider in this sort of an issue. So the long story short is that we have a very resilient service, in the sense that if a service dies, it's automatically restarted. If the cluster is deleted, it can be restored in about 4 hours maximum. And the managed AWS services keep the stateful parts of the application carefully backed up at a very low cost. It's easy to scale, in the sense that if load increases, pod and server infrastructure can scale on demand. We don't really have to think too much about adding a server. That this is relatively simple. It's easy to add new countries. So if a new country came to Ronald and said, hey, we want to put .stat on the platform, we want to put our dissemination portal on the platform, then that would be something that, in principle, if you exclude design customization, that could happen in as little as a day. That could be a little ambitious, but that's just saying the actual work time. So the effort that goes into that is much less than what went into it the first time. So it's also very portable. So in principle, you can run this anywhere. You can run it on your laptop. You can run it on the cloud. Deployment is reproducible, quick, and automated. And the end result is a reliable, reproducible, maintainable, and economical service with a lower total cost of ownership. And I do want to say that, a lot of this is our contribution was in tackling a very small part of the deployability. And the software itself is built and supported by the OECD and the SISCC community. And they have a large group of people who are working on .stat and who are making it a better product every day. And our contribution really depends on that, and we're building on top of that, if you will. So we're very grateful for their work. So one of the key takeaways, I feel, is just as the data migration and the data modeling couldn't have happened without strong interagency collaboration, the same goes for the infrastructure side, which underpins all of this. we couldn't have done any of this without generous assistance from a whole dictionary of acronyms that are on the page, and we're very happy that we were able to get this support. A few of the other things that struck me as I was putting this presentation together was how
Sean, I'm
yes.
going to jump in and just give you a 1 minute count warning.
Perfect.
Back
okay.
to you.
So I'll be done in 30 seconds. So strong institutional capacities in software engineering are essential to running distributed systems like .stat. And running this infrastructure may be invisible, but it's fundamental to data dissemination. So the last point I wanted to make is taking something complex and making it simpler requires a lot of effort. And I'm very grateful to, having worked with Peter Zandbergen and others who helped make this what it is today. So that's it from me. Abdullah, over to you if you want to do a quick demo before we hand it.
Okay, I assume I have 30 seconds. Okay, so the current status is that CompStat is up and running at the UN Global Platform. You can see it on the screen. It is available in English and Khmer languages, and work on introduction on increasing the coverage of Khmer is ongoing. With all the benefits that the UN Global Platform brings, which is availability, reliability, scalability, security. Most important point I would like to make. This system is very powerful, great. It covers over 50 data sets, and it covers a whole range of statistical data from health, education, economy, sustainable development goals, practically the entire range of Cambodia statistical data. You have rich text, you have text search, you have you can search, you can browse the data in English and Khmer. But this software, while very powerful, is also quite complex. And deploying it requires an expertise which is hard to find in statistical offices and even more difficult to retain. And this part of the complexity is taken care of by the UNGP community, by the global platform community. Responsibility for deployment and maintenance of the software and the databases is with UNGP. And the Cambodia National Institute of Statistics can concentrate on its core competencies of data management, data maintenance. This is what nobody else can do except themselves, and this is what they can focus on. This is what they can concentrate on. So all this whole layer of complexity is taken out of the equation by running the software at UNGP. And I think my 30 seconds is up.
Abdullah and Sean, thank you very much for that. I mean, listen, that was a very different use case and example, but I think a really powerful one of how some of the hard work and technical work that goes into developing and supporting a platform then gives you benefit back to lots of users in the community in terms of reuse opportunity. And that's maybe the theme across all three talks. So we've seen about the data sets and reuse from the Earth observation and the way of reusing that same source in different countries. We've seen from the AIS the idea of the methods and comparable methods being reused by different research organizations and different areas for some of the different research questions. And then here we see a way of supporting some of the statistics publication and dissemination out through a robust platform. So there's some really great examples here. Listen, I think maybe what we have very quick 1 minute for any urgent burning questions. But if not, I suggest we pick those up via email, because I'm sure for Sean and Abdullah, there'll be lots of how can we do that in our area questions. I'm going to pause for 2 seconds, just see if there are any questions coming in. Do put your hand up if so. No, thank you. Great stuff. Listen, thank you again. And I'd like to thank Sean and Abdullah in the same way as the others. So please come off mute.
Bravo.
Excellent. Thank you very much. And I have Risengo, I don't know if that's you trying to come in.
No, I wanted to give my applause in person on the video.
Excellent. It's nice to see you. Thank you.
Thank you.
But listen,
Thank you.
I think we are out of time, but for me that was 3 really fascinating and different presentations covering the range of work. And I mentioned that the platform business model, a platform is there to support reuse. So if you're talking about data that you can reuse in many contexts, many countries, many research questions, about sharing methods, I talked about at the beginning, and I think each of the talks showed that, and about this idea of the community, the reuse and sharing and collaborating with our experiences. And the big data platform, the global platform, really helps and underpins some of this in different ways. So I think there were just 3 great examples there. And I'm going to close. I haven't got time for a long presentation, you'll be pleased to hear. But one of the things that we often used to talk about was that big data gives you the opportunity to do things faster. So with less of a time slip before your results, your analysis is available, but also cheaper in that many of the sources are already collected from other groups. So it's not something that we have to go out and collect separately. But I think what I've seen today, and I think the examples are also, it's about better, which is that it enables you to do things that were really very difficult to do using traditional sources of data. And so that faster, better, cheaper model for me is a really powerful one and kind of maybe underpins a lot of the interest in big data and official statistics and so on. But listen, it's been a great session. Thank you all for participating and the great questions. I know this conversation will go on, but once again, thank you to all of our speakers and look forward to seeing you soon. Thank you.
Thank you very much.
Thank you very much.
Thank you.
Thank you, guys.
Thank you.
Thank you.
Thank you very much.
Thank you.